Hey, what up, dudes? Alright, we back. We're back. Basically, we're doing the same exact thing. We're doing the same exact thing that we were doing. Alright, yeah. I was thinking, I was downloading my information. You know what I'm saying? Had to connect to my Neuralink had to connect to the Starlink. You feel? Ooh, 12:57. Okay. So we took a little hour break. Well, hour 12-minute break, matter of fact. And we're gonna do. Try and do another hour and a half. Let's go ahead and set that timer, dog. Set that timer. We'll do 68 minutes. You know how it is. 68 minutes, kind of a long time, dude. You know what I mean? It's a long time, bro. 68. That 68 is kind of rough, dude. All right, there it goes. So, yeah, we deviated a little bit from what we were doing, which is going through client. We discovered some stuff, albeit minor, like nothing that's gonna cause the game to break, but stuff that needs, stuff that needs to be cleaned up a little bit more, fixed a little bit better. So we're gonna take care of that later. We made our things to do over here to take care of those things. It's like these first 6 or so. It's not gonna be too hard, honestly. It's gonna require, being careful and all that. Reviewing server is gonna go along with it, so it kind of makes sense for me to probably do it whenever we review server. Like, I don't want to review server. I'm gonna be honest. I don't want to review the server file, but I don't want to do it. I really don't want to, but it has to be done. If I don't do it, then I'm just gonna have a hard time debugging it. I already know, cause I already know there's some stuff in there that ain't finished, dog. It ain't finished all the way, so I'm not gonna like pretend. I can sit here and pretend like everything's gonna be all good, but it's not. So let's finish this client file though. All right, so here we are for tubing client. So this is the apply application section. We have our apply list created. We check our client ID. We sort that receive cal tup list based on the apply counter. Okay, that's great. Then for tubing receive cal tup list, so we're iterating through it. We get the sender ID from it. We then check the why we got a div right here, I don't know. Anyway, if client ID is equal to 1, we go for the C1 apply counter. So we say tup4 is equal to, so that's checking if the apply counter matches the expect counter. We append it to the apply list and increment that expect counter. Okay, then if it's client 2, we do the same thing, but using tup5, right? We append it to the apply list for data application. Then we do C1 and CG expect counter increment. Then we iterate through the apply list and we get the dir string variable. I don't even know what that is. Just the dir string. Gotcha. It's just the dir string, directory string. And directory string is actually kind of accurate because, oh yeah, I remember, because it's like a file. It's like directory. It's a file check. It's fine. We're not gonna change that name. It's not perfect, but whatever. Tup sender ID at tup -1. Tup sender ID is equal to tup -1. That's indeed correct. Now we get apply receive data function, passing in the client tup sender ID, the dir string, the adder name string, the receive data, and the receive timestamp float. Okay. So client tup sender ID, dir string, adder name string, receive data, and then receive timestamp float. Okay, then we have client And let's put this note here separate. Reviewed and verified this is the proper object reference. Removing from the index 0 is proper. Deletes the current iteration. Yeah, so we need to... I like having things on their own line. It just makes life easier. So I fucked up. I meant to delete that. So let's highlight it. Highlight that. Delete it. And then we're pasting it in. We're going to have this shit right here. Table line create 22924, node 42924, view to verify this is a proper object reference. Removing from the index at 0. Removing from the index at 0 is proper. Deletes the current. Why do we say reviewed and verified this is the proper object reference? Removing from the index 0 is proper. But we don't remove from the index 0, we remove the entire tuple. Deletes the current iteration from the order list. Nah, bro, it's not the order list. It's the received cal tuple list. See, all this little stuff, it adds up. All these little like mistakes and not being specific or not updating your comment, I'm telling you, dude, it snowballs out of control if you don't take care of it. Deletes current iteration from the received cal tuple since the data has now been applied. Okay, that's fine. But we don't do nothing with no index 0. TLDR, have to use remove because received cal tuple list isn't a 1-1 exact match to apply list. How do you use remove because received cal tuple isn't a... I don't even know why we have it say that, though. Have to use remove since we can't assume a static index because not every element in the received cal tuple gets applied in order. This would be required to use that method. Due to problem mismatching with binary. Gotcha. Okay, I see what I mean, but... Yeah, because not everything in the apply list, not everything in the received cal tuple list is in the apply list. Yeah. Okay. Yeah, so that's accurate. This, though, there's no removing at index 0. I don't know what this meant. So we're going to get rid of that. Below section, note 724. This section will only be utilized if when we implement the perfect save system. Currently, we are opting for the periodic save point system, which is more simple and would roll back all of the data changes made from this iteration of the receive section of the main while loop. Removes the tuple from the associated change attribute list. From the associated received data storage dictionary since it has been applied. Then checks to see if all tupes have been applied. Hold up. Removes the tuple from the associated change attribute list from the associated received data storage dict since it has been applied. Then checks to see if all tupes have been applied from associated change attribute list. If so, removes key value pair from associated received data storage dictionary. Okay. So then we have sender ID is equal to tuple1 gets the ID, the data was received from. Have to do this before below line since it chops off this ID element. Then we say send gets the ID the data received. You don't have to do this before below line since chops off. Then we say send ID is equal to tube at -2. And the tube is -1, -2, so it's send ID, okay. And then we have tube is equal to tube 0, 1, 2, 3, 4, 5, right? So it gets it back to its original state. And that would be timestamp dir string adder name data C1 and C2. So it's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Gotcha. Okay. And then we have if client ID is equal to 1, if sender ID is equal to 1, proper received data storage is C1 to C1, else proper C2 to C1. It's 2 to 1 for receive, and then otherwise it's client to sender is 1, then it's 1 to 2 received, or it would be 2 to 2 received. Associated received change attribute list is equal to proper received data storage that send ID at 2, blah blah blah. Associated received change attribute list equals proper received data storage dictionary at send ID at 2 refers to the change attribute list in received data tuple sender ID send ID change attribute list. Man, that shit's complicated. When it's added to the received data storage dict, is that proper though? Is that actually right? At the send ID is the associated at index 2. So is that correct? When it's saved, is that the correct reference? Let's see. So at the point of saving, the format is going to be this format. It's received data. And what is the received data format? Core data. So core data is going to be shit. Okay, core data is going to be at index 2. That's going to be the change attribute list, receive, send ID, or the resend. Let me clarify on this right here. So I know. We'll say dot receive data will be in one of 3 formats, and then the core data is going to be, well, if it's a change attribute list, so that's not actually we get saved. We get saved would be the change attribute list format, right? God dang it, man. God dang it. Let's see if we can find this. Receive change attribute list. So this is if it's a list. There we go. That's what we're looking for. Elements. Timestamp, dir string, adder name, data C1, C2. That's what it's gonna be. Right? This is giving me a headache, dude. This shit right here, dude. I'm gonna get it. It's like working on fucking calculus, bro. It just makes your head hurt. You know what I'm saying, dude? Fucker. Where's the stupid ass line I'm looking for? It's right here, dude. Where is it? See, and this is why I'm trying to trim it all down. Because the less code, the less confusing, the less time it takes me to jump from one to the other. I'm like, where was I looking? For tube and apply list, okay, we are down here. Proper, yeah, right here, okay. So we wanted to remove the tube. Associated receive change attribute list removes the tube associated, and then we have remove the entire storage since it has been applied. Change attribute list removes the tube from the associated received storage This is not right. That comment is wrong here. So what we're doing is we're iterating through the apply list, we're applying the data, we're removing the tuple that's been applied from the receive cal tuple list since we already removed it. And then we're restructuring the tuple to be what it previously was, to its original state prior to the post-receive modification. Then we're getting the proper receive storage dictionary. Then we're accessing that storage dictionary's value, which is the entire changed attribute list. Reduce refers to the changed attribute list and receive data. So yeah, that's what it was. Sender ID, send ID, change attribute list. I tried to verify that, but it's not noted up above. So I'm just gonna trust my correctness that is how it's modeled. You know, we're just gonna trust that, right? So if the associated receive change attribute list is equal to proper receive data storage data send ID at 2, okay, that is the associated receive change attribute list that we stored in the dictionary. So why do we do that? So we remove from it that tuple. Right, because the change attribute list could have various data, more than one tuple. Each tuple is a data point, I guess, right? So it removes the one that it just applied because we don't need it anymore because we applied it. So we're removing it from storage. Removes the two from the associated receipts of storage dict. Change attribute list since we've applied the data. And then if the length of that change attribute list is equal to 0, then we would delete that proper received data storage dict entry entirely, since all the data from it has been applied. Okay, I understand. So the ultimate goal here is we're using the storage dictionary to hold on to all received data until we apply it. But the actual place that applies it is the apply list. Okay, that's fine. Yeah, that's good. That's good code. I mean, sure. Do we actually need that? Do we actually need to store the received data in this dictionary? I mean, I would say I don't really know. Like, what is the point of having it in the received data storage dictionary if it's already, like, if we save the overarching list, which is the changed attribute list, which contains those data points, then do we actually need to also have this received data storage dict? I don't know. If we have that storing, well, it does have extra data that the change attribute list doesn't have, right? We do save the, which one is it? The received caltube list. But that doesn't really matter because, well, no, that's not true. Because if we have one that's out of order, like if we have 7 but we don't have 6, if we had like 4, 5, and 7, we would apply 4 and 5, but not 7. So 7 would remain in the received caltube list until we received 6. So whenever it went through this while loop iteration, that would get saved. I'm still questioning, do we really need the received dictionary? I know I'm getting hung up on this, but that's because there's a lot of just clutter, confusing code. It's not a lot, but it's enough for me to ask and address it. Do we really need it? Or, like, couldn't we just make it to where it gets saved, like it gets stored in that dictionary when we receive it, and whenever we, like, why do we need it? I feel like we do need it, but I can't say why. If I can't explain why I need it, then I don't think I really do need it. I'm just like, but we might. For what? To restore the data if we crash. But what data would be lost that wouldn't be recovered? Because it's all atomic. We save once per while loop iteration. So, it doesn't matter if we receive it. We save right here. Correct. We don't save again until we get to this point again. Therefore, our concern is whether or not we should be saving this, putting this received data inside of a storage dictionary. Because if we receive it and haven't yet applied it, and then it crashes, how would it get recovered? Well, so think about it. It crashes. After a while of iteration, it saves. Then it crashes, comes back on. It receives data. Let's say it crashes right here. It received all this data. It puts it in the storage dictionary. But that doesn't matter because the storage dictionary is not going to get saved until the next iteration anyway. Then, so we receive the data. We extract the receive change attribute list from it. Then some of it needs to be applied, but some of it doesn't. And that's just the way it is. Some of it is not going to be received yet. It could come in a different send. That's just how it works. Then, so we might have received data, but not applied it. Right? I might have to use Paint for this. I might have to use Paint to visualize it. Because honestly, it's making me angry. I'm getting mad. I don't want to spend any more time on it. But it's not something that I can just ignore. I have to make sure this is right. So if we receive the data, we begin to apply it. Let's say we only apply half of it. The other half we can't apply because it's not ready, like it's out of order. So then in that case, we have data that was received and then partially applied. troop in the client receive change attribute list. So as we apply the data, we remove what was applied from the received storage dictionary, so that when we hit the next iteration, everything that was applied will have been removed, and any data that we received that has not yet been applied would remain in that dictionary. So that makes sense. But then we have the receive change attribute list is the list of data equals the core data. Shouldn't we append it? No, that's not the receive change attribute list equals core data. This is only if we receive. If we receive it, in a while loop iteration, we extract the core data from it and place it under the namespace of the receive change attribute list. And then we begin iteration through that receive change attribute list. Okay? As we iterate through it, we append to the received caltube list. So if we sent data but it got lost, then the receive verification system that we're going to add would handle that.
But there are times it is
But I was concerned about, what about whenever we received data but only applied some of it? And that's what I'm reviewing right now. So we have it received, the core data becomes the change attribute list, and then we iterate through that change attribute list, and we append each tuple to the received cal tuple list, modified. And then, so that just modifies it. It literally becomes the received cal tuple list. There's no difference. It's added. Okay? And then we begin to apply the data. Then we just say if the length of the received cal tuple list is greater than 0. So that's all the data that needs to be applied. That's every piece of data that needs to be applied. Ends up right here. Then we iterate through it and see if it needs to be applied, if it's ready. Now let's say we apply some of it, and then we get all the way through here. We remove the tuple from the received cal tuple list because we just applied that data. And then we draw the window. They check to see if they need to send anything that's completely separate. And then the while loop starts again. So if there was anything that was received but was not applied yet, it would be handled through the save system, because that data would still remain inside of the received cal tuple list. It just hasn't been applied yet. And since the received cal tuple list gets saved, that handles it. So we should be safe here. And I already went through this all before with the perfecting the data exchange system and everything. I had to clear up that concern I had. So honestly, I think we're good. Yeah, I think that makes sense. What do we do here? I think that makes sense. Yeah. Alright. So we're done with that section. Okay, now to receive, or now to the send section. And as far as the receive data storage dictionary goes, is that redundant? Well, I would say regarding the data application process, it is redundant, because all that it does is it holds on to the same exact data that's already being held onto, right? It's still being held onto in the received cal2 list. Forget about it. I wish I could. No, not really. I can't forget about it. Yeah. We don't need it. And I understand that this is how, like, we have the received change attribute, the received storage dictionary. But I don't think we need this. I think we can just get rid of this code. This whole little section right here, which says proper received storage dictionary, from here onward. Why do we do this? To reassign the duplicate form to its original state prior to post-receive modification. Why do we do this? What's the purpose of that? Sender equals 2. This actually only be utilized if we implement the perfect save system. So there needs to be a div here. This is an entire section. Right here. Now I gotta get a handle on it, bro. It's just the way it is. I can't. I have to understand it completely. I have to. It just has to be. And if I can get rid of this, oh, that would be so, ooh, if I just delete this whole, ooh, if I can delete this whole section, I would love that. Ooh, man, it would feel so good. Because all this does, so we remove it from the received cal2 list, and all this section does is that it does the same thing that this one line does. We save this. So any data that hasn't been applied would be saved in this received cal2 list, right? Yeah, I believe. I do. I believe it. Because I'm almost certain now. Receive. Extract core data from receive. If it's a change attribute list, of course. Right? Then we go down here. And let's see. Yeah, if it's a change attribute list, we just give it a new name. We extract the core data. We give the core data a different name. Then we iterate through that core data. We add all of it to the received cal2 list. We sort the cal2 list. And then we sort the cal2 list. Then we begin to apply it, all the data from that core data. And anything that's in the core data that needs to be applied, if it's in the right order, we go ahead and apply it. Anything that's left over that has yet to be applied remains inside of the received cal2 list. So all, being very specific here, all received data point changes don't need to be saved anywhere else because they're already preserved if they haven't been applied in a particular while loop iteration. They get saved inside of the received cal tube list, just in case we crashed. If we crashed at the beginning of the loop, and we restored back, we could load the received cal tube list and apply that data. It's not going to be lost. There's no reason for us to have to refer to a received data storage dictionary. See that? There's no reason. We don't need to do this. I don't know why we do this. This tuple reassignment for above line. Why do we do this? Sometimes where I just look back at my code and I wonder, why did I do that? And I hate to think that I didn't have a reason. I hate to think that I was just that dumb. You know, maybe there was a reason, but that doesn't matter. If there isn't a reason now, it's dead to me. It's dead code and I need to get rid of it. Because ultimately all this received data storage dict ends up being is for data recovery on a crash. But that's not how it works. The data is stored inside of the it's already stored inside of the received cal tube list. Now, we will need the received data storage dictionary to take care of, well, I don't even know if we necessarily need that. We actually, I don't think we need a received data storage dictionary at all. Why do we need to hold on to the entire amount of data that we receive? As long as we save, like, it either gets fully applied or it doesn't. If it's a resend request, it's gonna get fully handled inside of the while loop iteration. If it's a receive verification, it's gonna get handled within the while loop iteration. If it's a changed attribute list, that's the last third thing it could be, then everything that is able to be applied will get applied in that while loop iteration. The only thing that will not get applied will be saved. It will be stored inside of that received cal tube list, and it will remain there just in case we crash in the meantime. Now, what that means is there's no reason to save the entire received data, because we have a receive verification system, or a resend request system, right? Wherein if we haven't received the data, let's say the server sends us a resend request. If we implement the resend request system in properly, that means whenever the server sent us a resend request and we crashed in between applying it, that means when we load back up, that resend request is just gone. The server already sent it and the client lost it, right? It didn't get done. We didn't handle it. But that's why we have in the receive resend request. So whenever the client starts back up, it's gonna check to say, hey, we have data that needs to be applied. We've received and applied 1 and 2. We've received and applied 3 and 4. But we've received 6, but we never received 5. So then it's gonna go and ask. It's gonna go and ask. It's gonna go and ask the sending side for that data in the form of a resend request. So that receive verification that they sent us that got dropped, we don't use the receive data storage dictionary to refer back to it. We just don't. We're gonna use the resend request system because, well, ultimately because even if we stored it and saved it, it's kind of pointless because it would get taken care of within that while loop iteration. So either it would be taken care of completely by the next one, or it would be not taken care of and saved. That wouldn't happen. It would just get saved, and then it would get handled, and that just is silly. Why would you save it if it's already done? If it's done, what's the point of holding on to that? There's no reason. The only reason would be if we used a different system, and we're not using that system. We're not using the receive data storage dictionary. We're using the resend request. Yeah, we're going to disable this. We're going to disable this entire section. And that reminds me, that's why we need to use, let's see, resend request provision. Currently, I believe there's a send side system. Resend request was resend. We want to make sure this is the resend request is on the receiving side, because we want the receiving side to be the one that says when it reconnects, or like you could lose data through a reconnect, or you could lose data through a network failure. The send side system only really, it's not specific enough, right? Like the receive side system makes sure that this would only happen when it needs to happen, i.e., whenever you have a receiving side like crash, it would be like a trigger as to where the other side, it doesn't really make sense. You know what I mean? Like it makes more sense for the receiving side to be the one. It's kind of like if you have two companies mailing boxes to each other. You wouldn't really have the sender determine whether or not the box needs to be resent. You would have the receiver make that determination. They would either get the box or not, and then say, hey, we didn't get this box. Can you send it again? That just is more logical. Other than being more logical, is there a good reason? I thought there was a really good reason when I was just going through what I was going through right there, talking about the receive verification and everything. If it wasn't received, or it was missing, it would ask for it, because the receiving side checks to see, okay, is this the next one in line? Oh, nope, this isn't, so we can't move on until we receive the one that's next in line. Yeah, so we're gonna, and then that would trigger. That would take away ambiguity from it. It wouldn't be based on time. It would just be based on like facts. Like, okay, it's literally not here, and well, we could wait a little bit of time to account for that, but yeah, so we're gonna do it like that. So let's say change it from being send side to being receive side. Man, it's a lot, bro. This data transfer thing is so hard. I see why people don't want to make online games. They are so complicated. Jesus Christ. It's just like, oh my god, the level of detail is, it's almost too much, man. It's a lot, dude. It's just bogs you down so much because there's so many little precise details that you have to take care of. Anyway, alright, so change from being send side to receive side, aka if receive side doesn't have the box send ID, triggers resend request after 10 seconds of non-receiving. And it just makes more sense this way. It just makes more sense for the company receiving the box to request another one rather than the sender. Yeah. Alright. I'm getting big mad because I wanted to be done with this. And that's what happens, man. You get mad because it's not going as fast as you want it to go. And that's just the way it is. So we're going to say decided that we don't need to store or think of how to word this because I want to be clear. I don't want to be confused in the future and be oh maybe I should re-enable it. No. I got to be really clear. We don't need to store data point changes, i.e. changes from received changed attribute list inside the received data storage dict to ensure that all of that data gets applied. This is because it is already ensured to be saved / applied via the client.received cal_tup list. This also raises the question, I don't want to put that right here. That doesn't necessarily have to do with this section. So that we don't need to sort data point changes, i.e. change from received data to inside the received data stored to ensure that all the data gets applied. It's already therefore, we don't actually need this section because all it does is mirror the removal of the data done directly above from the client dot received cal_tup list. It is mirror the removal of the data to also be done in the received data storage dictionary. And yeah. Say data from received changed attribute list will already be saved, be applied / saved. Dude's an idiot. Dude's an idiot. Will already be applied save via the client received cal2 plus line above. Copy that. Change this. Say we do not need this section because all it does is mirror the removal of the data from the received cal2 list directly above to also be done in the received data storage dict. Just because all it does is mirror the removal of the data from and then yeah, there we go. i.e., there is no need to rely on the received data storage dictionary for data recovery in case of crash. The clients.received cal2 list handles that. That's about as perfect as we're gonna get. Okay, so this raises the question though. Well, let me finish this. Disabling as determined. We do not need this section. Keep it nice and short. All it does is mirror the removal of the data from the client received cal2 list directly above to also be done in the received order suit. It will already be applied save via the cal2 list. Yep. So this whole section right here is going to get commented out. Leaving until, let's put that on a separate line here, so we don't have to scroll through. Leaving until leaving it until I am 100% sure decision is correct, which we're pretty sure it is, like very sure. Alright, and then we have to put over here, do we actually need, let's put this by the storage dictionary, clearing received data storage dictionary. Necessity of received data storage dictionary. After further consideration, I'm not sure that we actually need this this at all. Since save is done 1x per main while loop iteration, and receive verification, resend request, and change attribute list unless unfinished, which will be saved in client.received cal2list, are all completely handled within this atomic operation. Therefore, what is the point in storing this data if it simply isn't needed? True. And that's all we need to say. So we very well may end up getting rid of the change attribute, the received, whatchamacallit, the received dict completely. Like 100%, which is fine. I would love that, because as you can see, there's a lot of code that's associated with it, and it clogs everything up and it makes it hard to read. I would like to just delete this code, but I think I'm not gonna do that. I'll leave it until after we do some testing. Okay. So I gotta go piss real quick. I'm gonna take a little break, and I'll be right back. Okay. I'm gonna go take a little walk, take a piss. I'll be back. Okay. We're back. Now we gotta finish this, man. We gotta finish this, eh? Alright, let's finish this client file real quick. Probably gonna take a break after that. Like, I mean, actual, like, I might stop for the day. How many, where are we at here with time? We did an hour earlier. We're at an hour 24 minus 10 for my break, so hour 15. So we're 2:15. Really like to be 3, so that would be 45. We did 45 more, that would put us at 3. I'll try to do that. Let's set our timer. We'll do 40 more minutes. And then we'll cut it out. How about that? That seems decent. Alright. So here's our send section. Draw window main. Then if client ID is equal to 1, we see if the length of the C1 change attribute list is greater than 0. That means we change something during draw window main. Client.change attribute list is equal to C1 change attribute list. Else, which is elif client ID. One if things. We check the length of the C1 greater than 0. Don't have to lock here since it's CS true. Then client.change attribute list is equal to the C1 change attribute list, and this would be else. That's either if client ID is equal to 2, then we're going to do if the length of the C2 change attribute list is greater than 0. Client.change attribute list is equal to C2. Okay, then if the length of that client.change attribute list is greater than 0, we can check the client ID to determine which send ID to use for sending to the client. Checks the client ID to determine which send ID to use for sending to the client. If client ID is equal to 1, send data storage is equal to C1 to C1. Send ID equals client.C1 to C1, and then we increment it. And then if client ID is equal to 2, we're sending from 2 to 2, right? Because we don't cross send on client side. We only send to directly to the server, to the corresponding client. So we have send ID equals client C2 to C2. That's right, C2 to C2 send ID increment. Pre-serialized data is equal to client ID, send ID, and then change attribute list. I'm not sure if that's right. I'm going to assume it's right, even though I don't have my discount double check there. Data is equal to pickle dumps, pre-serialized data, format, send ID, change attribute list, message head. So we create the header, passing in the data. Yeah, and we want the header done on the serialized data, right? Yeah. True. Right. Okay, then we have a log here, client ID, send change attribute list, and then the things that we changed. Then we do con send all, message head plus data. Stores the sent data, send change attribute list until the client verifies it received. In case of D6 header, in the case you need to resend the data. And that's perfectly fine. Send data store rejected, send ID is equal to pre-serialized data. Okay. Then we say client change attribute list clear. So we clear everything that was sent over the network. Here's everything that was sent over the network from the client.change attribute list and C1, C2 change attribute list, since they refer to the same object. This can be done on client side. Wait, what's this? This can be done on client side since single threaded. Okay, I'm assuming that's correct. Then we end the send section. Then that's the end of the main while loop. And then we have except here. When we encounter the game crashing errors or solve disconnect, in that case, it enters into this exception and sets solve reconnect will equal to true. Otherwise, if it was a hard disconnect, that wouldn't happen, right? This will avoid triggering the preliminary database setup code at the beginning of outer while loop, since in case of solve disconnect, we don't need it to be run again. I think that's right. We put the double check on that. Well, this is really only if we encounter... Well, yeah, game crashing error is not technically a hard disconnect. So yeah, this is right. And then we have this final except. I don't know what this is for. What does this correspond to? So that's the main, that's the second line from left, except pass. So this is the outer while loop exception. So this will just say outer while loop try except. Outer while loop try except. And what do we do in that case? Well, I guess we should at least have a... We should at least have an output, right? We should have a traceback. So we should say custom logger dot traceback print log function f, and then we'll just say client pi. And what's the format here? We'll copy this, starting at f. So we have fcl pi client ID, and this is going to be outer. Let's just put this here. Outer while loop try except. Okay. Now we probably need to expand on this more. Like, what do we do in that case? What do we do in this case if we have this exception? Well, I mean, ideally, we would want to re-enter back into the main while loop, right? Or the outer while loop, right? But that's not, like, in a function. So it's not like we can just call this function again. Really, there's no way to reroute us back inside of it. I would say technically we probably should have that. We should probably put the main while loop inside of a... Yeah, I would say this is probably... Well, I mean, it depends on the exception, right? And like ultimately the goal would be, well, if there is some sort of exception, we're not planning for this. Like, we should never be here, right? So if sometimes people use exceptions as like a planned track, but we don't plan for this. If we enter into this, that means something's fucked up in the game. Like, something is wrong. So rerouting back into the game in this case would actually just like be avoiding the problem. So we should really just add that as a note. We'll say should never enter here means there is a big problem, or is a problem somewhere, not necessarily a big problem. Yeah, so I think that's good enough. We don't even need the pass. We'll just do that. Alright. Lord have mercy. So we finished. That was a task, eh? So we reviewed the entire client file, and we found a lot of things. Not a lot. Like, sorting through it was a lot, but it was really just a couple things. It's mainly the receive data storage dictionary, receive verification. That's pretty much it, actually. Just those two things. The questions I had about the security of the data exchange was validated. I just had to like review it. So let's go ahead and we'll say finished review of entire client pie. Now we're gonna begin review of entire server pie. And I don't want to do it. I really feel like kicking and screaming right now. I just don't want to do this, but it's gotta be done, dude. Let's go over here. So next is gonna be continue entire file review of server pie, making a single pass since we refactored a lot and left behind a lot of to-do question comments that need to be addressed prior to the game running debugging. All right, so let's go over there. I guess we'll just start at the top. Server's worse. Oh no, don't say that. Server's worse. I don't know if it could be worse. Just you wait and see, big dog. Alright. Well, we made it through. Alright, we made it 187 lines in. What is our first problem? Shouldn't this namespace be changed to server IP address to be more specific? Oh no. Let's see. Is that true? Shouldn't this namespace be changed to server IP address to be more specific? Get FQDN gets the local machine domain and then get host by name. And then get host by name translates that domain into an IPv4 address. This way we don't have to manually update the IP address here every time the IP is changed. For whatever reasons, this will always be the host address. You need to create a final version of this code that will reflect the fact that the game is remotely hosted. However, that will be done in its final state. Okay. I mean, I don't know. Let's pass it to the God and see what the God has to say about it. Let's pass it to the Lord and see what the Lord got to say. Yes, based on your comment history, it looks like self-server is intended to store an IP address, specifically the game's server IPv4 address. Right now, the name self-server is vague. It could mean a host name, an object, or even a socket connection. Renaming it to something like self-server IP address would immediately communicate that this variable holds an IP address, not the server object itself. Also, from your comment, I'd point out that in a final remotely hosted setup, you probably won't want socket FQDN at all. You'd likely have a fixed domain name. Yeah. Our configuration setting. This way, you're not relying on local cheats. If you want, I can show you how to make this variable name change. Okay, cool. The God has spoken, and we will go ahead and roll with it. Change server IP address. So we're gonna do that. We're gonna change this to server IP address. So this is an easy change. I love those, right? Self-server. They don't make you strong though. They don't make you strong, do they? So let's do f.server. We'll just search for a server, and we'll pick out the things that we need to change. So let's go up here. Represents which kind of the entire server from server side, server client, server. This is saying that it's a socket, but I don't think that's true. It's not actually a socket. Yeah, it's not. That's not true. That's not true. That's not true. That's not true. Alright, so we gotta change it. So this is gonna be changed to server IP address. Yep, change that one. Looks like we already changed that one. Okay, so that's for the reconnect socket. Server IP address equals socket host by name. And then we have the... Okay. Okay, I see. So this right here would be server equals socket.getHost by name socket. That's the same thing. Why do we... What is this? Why do we do this here? Server bind and then listen. Why don't we use self-server? Why do we not do this? Why? We have server 1, client server 2, the server, all this. Name is equal to main. Okay. Why don't we use the server attributes? Isn't that what we're supposed to do? We have the server. Why don't we not just say the server dot server IP address? We don't even need to. So we have the server IP address already. It's gonna be the same thing because the time that this is created is at the time the game is created, which is the child process. The child process is gonna be like the server IP address is gonna be the same regardless of if it's a child process or the parent process. It's just going to be a different port. So we should use this object, self.server IP address. And we should also, well, maybe not self.s. Why do we even have self.s? Because we create a separate reconnect socket. Okay. And then we have this socket, self.s. But why do we... So regardless, let's go ahead and take care of this first. One thing at a time. That's what I'm learning here. You gotta just do one fucking thing at a time. So this should be this is gonna be the same. It's gonna be the same thing, dude. So we would just say the server, right? Why do I feel like I'm scared to change this? It's the same thing, dude. We're getting the host by name. This is gonna happen in the context of if name main. This is the main process, right? This is the parent process. And then wait. So that doesn't actually exist. The server is inside of the actual child process. So okay, I see. Gotcha. But this still should be called the server IP address. That is true. Right? Yeah. So we can still change this to be server IP address because that's what it is. It's the IP address. And then we're going to bind to the server IP address. Now, this shit, the server .ip address, I don't even know if that even gets used. Do we even use that? Out of curiosity? The only place we use it is right here. But how do they connect to it? Well, they don't connect to the server IP address. What was I looking for? Well, that's for the reconnect port because we pass. We create the connection in the main process, and then it gets passed to the child process. So it's not actually gonna get used, right? That's true. True. So we don't. All right. Okay. I understand. I get it. It's complicated. We got self.s. What about .s? Does that even get used? Does it? .s. Oh, and did we change the name? Yeah, we did. We changed it. And this is not a socket. That's wrong. So you gotta update your comments and stuff. Always remember to update your comments. So this is actually gonna be IP address. Yeah. Alright. Now we got .s. All this stuff here. And we don't want to look at capital. Here we go. Chopped out a couple of them. Server.ip address. This is supposed to be like so. Okie doke smoke. Okie doke smoke. Okie doke smoke. We know. So this should be a to do. Yeah. That's what you do. To do, baby. Yeah. Alright. So change. Whoa. Say below line to do below line. I can't remember the order. Anyway, it's not that important, right? Must be changed. One scheme is no longer local machine only. Must be changed to server IP address. One scheme is no longer local machine only. All right. Now let's continue with this .s. Is this even use it? If it is even use it? I mean, is it even use it? I don't think it is, bro. I got 50 bucks, dude. 50 major smackaroonies, dude. I guarantee you it's not even used. Garen fucking T it. Yep, it's not. Won't even use that shit. Don't even use it. Yeah, we don't need it, dude. How do we not need that? Commit after merge, diff, client by certify for fixing branches, stable and working 100% with multiprocessing. Ooh, don't even talk about merge. Don't even say that word, dude. Yeah, so that got deleted. There we go. It's always nice to delete code. That felt good. Port. The port. In this port, well, this is not just a port. This needs to be changed. It should be called the initial port, or the, we'll call it the main port. We'll call it the main port. How about that? Main port. Primary port. Main port, primary port. Primary does make you kind of feel like that means like there's a secondary. Main also kind of suggests like there's another one, so I'll just go with main port. But main makes you think of Dunder main and stuff like that, you know what I mean? So maybe I should say primary. Namespaces are actually really important. The names, they mean things. The words have meaning. Who would have thought? Who could have thought? Port. So we're going to change that. Yeah, we're going to change it to be... We'll just say primary port. It's not like we use it that much. I just like that better than main port. I don't know why. I just do. It's a prettier name. Port versus primary port. So the port's changed to primary port. And that's going to actually mess it up. Yup. See that? Yup. Now, look at that. This is going to be changed to primary port. Bam. Alright. Ensures that if the child process ends briefly for days, that upon reconnect, the port won't be timed out. And this is for the reconnect port. So I feel like we should specify that. We don't really need to. Reconnect. I mean, it's good, dude. It's just being very descriptive, very explicit. That is literally your job as a programmer. Every single character has to be perfect or it will not work. So don't judge me for being so syntactically, semantically psycho, okay? You have to be. You have to be, bro. It's not a choice. Reconnect port equals reconnect port. Bind, okay. The two can the IP address of string at 1 is the port num. What port num? This is individual game. So this is not the reconnect port, right? This section's going away anyway. We're gonna delete all this. This is all going bye-bye, I think. Yeah. Is it connected to the address string? Number 1 port number is integer. Adder 1. Yeah, we don't even need to change that. That's going bye-bye. Reconnect port equals reconnect port. Attempt to connect to a port. Okay, that's just a general description. What is this? Port. And we can't use server port here. Well. What do we do here? Which one are we at? Whoa! Free support port right here. 49152 are recommended as they're in dynamic private range and are usually free. Well, I like free stuff. Yeah. Port here. 49152. Yeah, this is definitely primary port. So honestly, do we even need the other primary port to be defined inside of server? I don't think we do. Right? S is equal to socket. Increments port. So it's a primary port plus equals 1. Increments primary port to be passed as the reconnect port. Wait a second. Yo! Oh, man. Somebody calling me, dog. Somebody calling me. Independence Leadership Academy. That's my trial school. That's my trial school. Anyway, call that back. They'll probably leave a voicemail. Anyway, alright, back to this. A port plus equals 1. Increments port to be passed as the reconnect port R to the job process. What do we do here, dude? I think there's a better way to do that. I think what we would do is say that we would define reconnect port out here as 49153, and then in the while loop we will just increment the reconnect port, right? We'll just increment the reconnect port one by one. So it would cut this line out to where we're not referring to the original port anymore. And I mean, there's no reason to pass the primary port to this section because it's not even used at all. Yeah, it's not used at all, right? So that's what we're gonna do here. We're gonna grab this boy. We're gonna grab this boy right here. Reconnect port passes individual game for reconnect port R for client reconnects. And we're gonna put that boy in his place right up here. Right? That boy's supposed to be way up here, and he's gonna be this number plus 1. So he's gonna be 49153, and then we're gonna go down here. we're gonna get rid. Well, we're gonna change this to say reconnect port. Get rid of that port. So we get that reconnect port plus is equal to 1. Increments that port, baby. All right. So it increments the reconnect. Oops. Reconnect port to be passed as the reconnect port arc to the child process, so the clients can reconnect through it. Increments because individual port per game child process. Okay. And that's gonna work, right? Because, well, you know, that's gonna start it off as. That means we should increment it after. Yeah, we should pass it because it's already incremented. So we pass it to the process. What you said, boy? What you said, boy? What? The port? You talk about me, dog? What? The boy said the port? Don't tell me, hold on. Keep using the fork? I don't know what he's saying. It's from some movie. It's that dude. Inconceivable. I don't know the movie. I know the dude, I think. It's from Honey, I Shrunk the Kids, dude. Yeah, that guy. Anywho. It's fucking inconceivable, dude, that you could ever think of something so dumb. So let's do this. Reconnect port needs to be incremented after the fact because you're an idiot and you put it before it. Well, actually, that was the right thing to do before. But now we don't want it to start off as 154. We want it to start off as 153. Then we'll increment it afterwards. So then it's going to be 154. It'll be 153 the first time. Primary port will be 152, so it won't be the same. Then it increments it to 154. So the next one it will be 154. Easy money. All right, cool. Yeah. Alright. Primary port. Yeah. 56, 57, 58. Yeah, there we go. Done. Ooh. Done, dude. Let's go back to the tippity top here. This tippity. Yeah. Where are we at here? I'm done with this shit, bro. I'm done today. I'm done for today. Yeah, it's that time too. Oh shit, with furious anger. Oh shit. Alright, this will be the last thing I look at. And we're done for the day, dog. First receive header. Header amount equals int header amount. Why do we subtract 33 here? Original size 34, so we end up with 1 byte. Yeah, we don't know. We don't know why it works. We just know that it does work. I'm not messing with it. I'll mess with it another time. Since this function is probably not going to handle reconnects anymore, we can refactor it to reflect that. So I'm not gonna handle reconnects anymore. Okay, so that's where we're stopping. We're gonna stop right here. Perfect stop point. The Lort. The Lort. $214 server by. Yeah. Wait a second. Oh, I'm tripping. What? I'm tripping. How I did my math wrong? Wait a second. I don't know. Anyway, don't matter. Alright. I did my math wrong, dudes. Did more than 3 hours. Okay, so game testing debugging review part 8, 8/8/25, 12:50. Oh, that. Wait, no, that's right. Yeah, 12:57 to 3:04. 3:04 X hours. That's how many hours? Whoa! It's 1 to 3. That's 2 hours. You will. Right. Continue debugging and reviewing the game to test specifically reviewed and removed the client receive time. Dude, that's wrong. That's wrong. That is wrong. We did that earlier. Finish review entire beginner review of an entire server client by stop at line 214 and server. Why it look like that? What that? What this little square is? What the hell is that? What the hell? A color selector, a color picker. What the hell? Where'd that come from, dude? Man, I don't know, bro. I just hacked the system. I hacked the matrix, bro. Anyway, I don't know what was up with that. Oh, okay. Whatever. Alright, so, yeah, that's correct. 12:57, 3:04, 2 hours. Continue debugging, bam, 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 bam. Alright. Root to the project directory. We are there. We're going to get branch. Make sure we are on the right one. We are. We're going to get add to stage. We're going to get commit. -M double. Bam, bam, bam. There we go. Now we're going to get push to push that shit up to the cloud, baby. Push up to the cloud. It's in the clouds. As we spoke it, there it was. Into the cloud. Now we're going to go into projects. Projecting my anger upon thee. I'm going to project my anger upon thee. My furious anger. Furious anger. Did I do that right? We about to find out. If we go to the bottom, and we did. Alright. There we go. Alright, dudes. Well, we did it. We made it through client. Was it a nightmare? I mean, it was a little bit. It was mentally a nightmare. Was it actually like, did it take me a long time? Not more than what I thought. It's about what I thought it was going to take me, so it's not so bad. Yeah, and it's clean. It should be good to run. Like, it's pretty clean as a whistle, other than a couple little flaws with things we already talked about. And server pie is probably a little uglier. It's probably going to take us, I would say, let's look here, just a quick scan. Looking at it, we're at line 214. We got to go through all the way to, we got to go all the way to 916, so those are like 700 lines or something. That's a lot of lines. I would say probably 100 lines per session. So that's like 7 sessions. So that's like 10 hours, 11 hours. That's actually a lot, man. Straight up. That's like 6 days. Just being realistic. Maybe it'll go faster, but you know, it usually goes slower than what you think, not faster. So Anyway, that's gonna be it for today. Yeah, so about another week we'll be done with server, and then we can finally just start spamming the uh, the playthroughs and debugging. And I don't think debugging is going to be bad. I'm just going to be honest. I think I spent so much time reviewing and like mulling over the code. I think it's going to be pretty damn tight, dude. I think it's going to be pretty tight. I'm going to say like 90 to 99% tightness, to where we're probably only going to spend like 1 day, maybe 1 week max debugging. So from today, you're looking at I'll say max 2 weeks to be completely done, and then we just gotta that means done debugging, testing the game. The game's perfectly stable. Then we're gonna go back and we're gonna fix the receive dictionary little thing and the resend request receive verification thing. That shouldn't take me but about a week max. I don't even think it's gonna take that long. I'll say about probably 2-3 days. So you're looking at 2.5 weeks max to actually be done with every single game's debugged, game runs perfectly, game is finished, other than like features that I wanted to add that I didn't add yet, like a menu screen. You know, that does need to be added. There's still like things that gotta be added, but it's little stuff. It's stuff that's gonna take me like a day or two max. You know what I mean? It's gonna take a day, maybe 2 days, as like the longest for each line item. So most of them line items are duplicates or nothing burgers, and so you can go ahead and chop them in half. And then also like the hardest one's only gonna take me about a day or two. So I'll say probably another 2 weeks to do the rest of that. So you're looking at about a month and a week to finish every single thing that's on pressing issues as well. Non-pressing, I'll say half of them ain't even gonna be done. The other half's gonna take me about 15-20 minutes. So that's probably gonna be another, let's just say a week. So you're looking at what I say about a month and 2 weeks, something like that. Is that what I said? A month and 2 weeks. Yeah, so by October, we'll be completely finished. Like, done. Then we just make the website for it. We gotta deploy it, post it on a server, get it to where it's an executable, and put it on Steam and all that stuff, or whatever we were gonna do. And I'll be like completely done. I say that. I'm gonna end up adding more stuff to it, but it makes me feel good to pretend like I'm actually not going to touch it ever again after that. So anyway, peace. Have a good weekend.